Okay, so we're going to jump here, and 6, 7, and 8 are all quadrilateral related. Okay, so let's jump right in. I'm going to put a little Q here next to 6, 7, and 8 to remind us that these are quadrilateral related kind of questions. Okay, and so there's only these 3 multiple choice, and then the one free response question on number 13. So that's going to be it. All right, so I hope that won't be too terrible here. So we'll see. All right. So number 6 says, given the coordinates A02, B42, C -3, -4, D -7, -4, what is not a possible name for the figure? So let's plot these, right? That's going to be our first step. So exactly right. So make sure we plot accurately, right? If you plot these points incorrectly, you're going to set yourself up for failure here. So let's do A02. Okay, and label your points too. It's not a bad idea. Okay, B is 42. C is -3, -4. Am I going too fast?
No.
Oh, okay. And then D is -7, -4.
Oh shit, I'm one up.
Okay. So there's my shape. Now I have to connect the dots. Now, the quadrilateral is quadrilateral A, B, C, D. So we go in alphabetical order. So that means I'm going to connect A to B. Okay. Then B to C. All right. And then A to D. And then D to C. Okay. And so, Matt, what kind of shape does it look like we have here in number 6? It is a parallelogram. That is right. Okay, it looks like a parallelogram. So, the question says, what is not a possible name for the figure? So, letter A, could we call this thing a polygon?
Yes.
Yeah, absolutely, right? It's like a polygon is a shape, right? Is this a shape? Yes. So it can't be A because we could call this thing a polygon. All right? Could we call it a parallelogram?
Yeah.
Yeah, according to Matt, we can. And you guys can kind of see here, right? What do we look for to determine if a quadrilateral is a parallelogram? Opposite sides must be what? Parallel. And if you look here, A, B, and D, C, don't they look like they're parallel? They both have a slope of 0, and we can count the slopes for C to B. So C to B is a rise of 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7. So it's a slope of 6/7. And let's do D to A. Its slope is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7. So its slope is 6/7. So is this shape a parallelogram? Yeah, absolutely. So we can't say that's the answer because, again, we're trying to find what is not a possible name. All right, letter C. Could we call this thing a quadrilateral? Yeah, absolutely. So it can't be C, so it's D. It's not a rhombus. Okay, we can't call that thing a rhombus. Why can't we call it a rhombus? All the sides are not the same. Measure, right? Clearly, A, B, and DC are same lengths, but they are not the same measure as C, B, or AD. What else is going to be true about a rhombus? What's true about the diagonals of a rhombus? They are what? They're perpendicular. And if you look here, if I were to kind of like connect the dots to make the diagonals here, like there would be my diagonal from A to C, and then from A to B. You can just kind of look at those two diagonals, and they do not even look perpendicular, right? Okay, so yeah.
Wait, it is a rhombus though?
So no, the answer is rhombus. But why is that the answer? Because it's not a possible name for the figure.
Okay.
The question was, what is not a possible name? So D, it can't be a rhombus. Okay, that's the idea there. All right, number 7. Each diagonal of a quadrilateral bisects a pair of opposite angles of the quadrilateral. What is the most precise name for the quadrilateral? So each diagonal of that quadrilateral bisects a pair of opposite angles. Okay, so yeah, not a trapezoid for sure. Yep. Okay, because again, if I like just draw a trapezoid here real quick, just kind of get an example of this. All right, here's like that, and here's like that, and it does not look like, for example, this angle is exactly bisected. Okay, so it's not a trapezoid. So what shape does have the opposite angles that bisect each other? Yeah, it's a rhombus. Very good. It's not a parallelogram. Again, if I just draw a parallelogram, a quick picture, well, shoot, even look right here. Here's a parallelogram we had in the previous problem, right? Does it look like, for example, the diagonal here at A, does it look like that diagonal is bisecting angle A?
No.
Yeah, no, this one's clearly smaller than that angle, right? Same thing is true for any of the other diagonals. They're not bisecting opposite angles. So it can't be a parallelogram, okay? And on the rectangle, again, you can just draw a little picture of a rectangle if you want to. I'm going to draw like kind of like a longer rectangle here. Okay, and if I draw my diagonals in, very clearly this angle is smaller than this angle is, so again, it can't be a rectangle, it's the rhombus. Okay? Alright, number 8. ABCD is a parallelogram with measure of angle B equal to 6x degrees and the measure of angle D equal to 2x plus 40 degrees. It then says, find the measure of angle DAB. So what might be a good picture, or, well, I already gave it away. We should probably draw a picture here, right? So let's draw a picture.
What? Dude, I told him to do that. That'd be fun.
What if we did like...
Do it then.
Well, you want to draw, it's a parallelogram, so you want to draw a parallelogram shape. True, but not every parallelogram is a rectangle. So you might be like introducing other properties in there. Okay. Now, I had to name this parallelogram ABCD, but did I have to put my point A here? No, I could have put it here and then done BCD there. Okay, it doesn't matter as long as they're in order. Listen up, Derek. Okay. So, ABCD is a parallelogram with measure of angle B equal to 6x degrees. There's my angle B is right there. Measure of angle D is 2x plus 40.
Oh, I know how to do this now. I just realized that.
Okay. So then how should B and D be related? They should be equal, so let's just set them equal. 6x equals 2x plus 40. Okay. And we want to solve this equation. So let's see here. So I'm going to pick someone.
X equals 10. It's 10.
So Josh, to solve this, what do we do? Yep, subtract 2x from each side. And so you get 4x equals 40. And then what, Josh? Divide by 4. And so you get x is 10. Now,
I guess substitute 10.
right, we got to be careful here. Did the directions say to solve for x?
No.
Shh, Jade and Brianna, listen up, girls, okay? The directions did not say to solve for x here. It said to find the measure of angle DAB. What's DAB? Well, here's DAB. This is DAB right here. So we don't know what that one is.
So don't you plug in 10 for...
So yeah, let's plug in 10 here for the x's. So 6 times 10, that means that angle is 60 degrees. And that means that angle is also 60 degrees.
It's 120, it's B.
So we could go this way. So hold on to that thought real quick, Jaden. Let me talk to Kyle, and then we'll come back to yours, okay? So Kyle, what did you say the answer was?
It was 120.
How do you know it's 120?
Because once you substitute the 10 in for 6, you get 60, and then it's supplementary, so then you gotta take 180 and subtract it by 60, and you get 120.
And also if you plug in 10 for the other form, you get 60.
Exactly right. So yeah, both these angles are 60 degrees. I could not explain it better than Kyle just did right there. So if you didn't pay attention, you really missed out. I'm going to say it again, though, for you those that weren't paying attention, okay? These two angles are 60 degrees. As Zari and Kyle were saying, you plug the 10 in for each of the x's, both will give you 60, okay? But we're not interested in angle B or angle D. I need to know what angle DAB is. I need to know this angle right here. How can I figure that out? Well, Kyle was right. A and B are supplementary. That means they add up to 180. So, if A and B are supplementary and angle B is 60, we can just do 180 minus the 60 and get 120 degrees. And that is the final answer. I want to point something out here, folks. Look at this. Do you see that in your multiple choice there, both 60 degrees and 10 show up as answers? Those are what we call distractor answers. Okay? What I mean by that is that, you guys in the middle of these problems, you'll be solving it, you'll see, oh, x is 10. And you might stop and think, oh, that's the answer, because there's 10, my answer's 10. But always make sure you're answering the question that's being asked. You want to find the measure of angle DAB. Okay? So that's that angle. You got to subtract 180 minus that 60 degrees. So please be careful here. The answers that are the wrong answers in multiple choice, they're not just random wrong answers. They're like wrong answers that are like common mistakes. Some students would stop when they see that x is 10. They think, oh, I'm done when x is 10, and they put that. Or some students would plug in the 10 and say, oh, the answer is 60. But again, they would say, but that'd be wrong because DAB is the angle we're trying to solve for, not B or D. Okay, so please be careful about that. Yes.
When you do in supplementary angles, when you do 180 minus 60 minus 60?
No, because just the two angles are supplementary. When you talk about supplementary angles, it's two angles can be supplementary. You have to, it's just two. So in this case, it's B and A. You could also do D and A. They'd be supplementary as well.
What about 360?
Okay, so great point. So Jaden, you were saying that all the angles have to add to 360, right? So that's true. So if I do 360, I can subtract off both of these 60s. Whoops. And they get 240 degrees. Now that means these two angles together make 240 degrees. Divide it by, you got it, exactly right. And guess what you get? You get 120. So that's another way to do it, Jaden. That would also work. Ari Kava, that would also work, okay? So there are two different ways there. Okay, questions on any of that? Good thinking there. All right, I like seeing that. All right, then let's move on to the last one we're going to look at here, which is, whoops, you can't see it because it's not going to fill the screen. There we go. Okay, so this is our last one we're going to look at, last free response question today. Okay, and I'll give you guys your assignment. So we have a bit of a shorter day today, but these can take a little bit of time.
Why do we have a shorter day?
Just because these questions are a little bit fast. I mean, not shorter day, I mean just like shorter, like practice and stuff like that. I'm sorry? Yes, but I'm going to get you started on it as soon as this is over, and if you get done, then you get done.
Can you show me how to do this again? I forgot.
Yep, we're going to go over that too, yes. Yes. All right, so 13 here says, complete the following questions given the points A has coordinates 1, -1, and you'll see they already plotted that in there for us, and B has coordinates 3, 1. Okay, so it's already plotted there for us. Okay, so letter A says to find the length of AB. Okay, and that's something we're going to skip and hold off till tomorrow to do. Okay, so we're going to hold off that tomorrow, so we're going to save that for Thursday. Okay, this is, by the way, a quadrilateral there. I also put a little Q there. Okay, sorry? Nope, tomorrow we're just going to hit some like missing like pieces. Yes, this is it right here, yeah.
Yeah, because we're going on a field trip, but I'm not
Right. Okay. Yep. Okay. Yep. I'll hit it then. I'll hit it real quick, and then we'll do some more with everyone tomorrow. And again, if you want to see more, you can see it tomorrow in the video. Okay. So there's kind of two different ways to do this. Okay. One way to do this is to look at this. Okay. And again, we want to find the length of this segment right here. Okay. Now, what I can do is I can create a right triangle, and I think you guys have kind of done this before, I believe. So if you make a right triangle from A to B, just like that, okay, what's the length of this leg? And I got to zoom into more here.
2.
So that length of the leg there is 2.
It's 2 by 2.
And it's also 2 here. Now, if we have the length of the 2 legs here, how can I find this length, which is the hypotenuse? What can we use? Pythagorean Theorem. So we'll do 2 squared plus 2 squared equals c squared. Okay? And I'm going to say that's 4 plus 4 is c squared, so that's equal to 8. I'm sorry? Oh, I'm sorry, you can't see. I apologize. I'll zoom it out some now so you can see it. There you go. I'm just writing right next to it there. Okay? And then to finish solving for c, to get the length there, what do I have to do? Square root both sides. So I get c equals the square root of 8. Now, again, we could get a decimal here. I actually want us to try and simplify this. So, yes, square root of 8 is equal to the square root of 2 times the square root of 4. It doesn't say here specifically that you have to put it in simplest radical form, so if you want to give a decimal, that's fine. If you want to just leave it as square root of 8, that's fine as well. I can take a look and see if it's going to be simplest radical form. Okay, let's practice the simplest radical form now because the calculator is easy. Just type in the calculator. So let's just practice this now. So square root of 4 is 2, so I'm left with 2 times the square root of 2. Remember when we look at our number that we're taking the square root of here, we look for numbers that we can break it up into perfect squares. So square root of 8 is the same thing as square root of 2 times the square root of 4. 4 is a perfect square. Square root of 4 is normal, just 2, and then leaving the square root of 2 there. Okay, so there's the distance. That's it. That's the length from A to B. Just Pythagorean Theorem there. Okay? Or like, yeah, 2.8 something if you do it in the calculator. All right, now the next thing, letter B. Plot and label coordinates C and D so that ABCD is a square and points are located at C, 1, y. So what you can see here is that they already give us what the x-coordinate of C should be. C's x-coordinate should be 1. We need to figure out what the y-coordinate is going to be. And same thing for D. D should have a y-coordinate of 1, but we got to figure out what the x-coordinate would be. So if we look here back at our picture, and maybe I'll do this in a black so that way it kind of stands out from the red work there. C needs to have an x-coordinate of 1. So if C has an x-coordinate of 1, that means it's got to be somewhere on this line. Okay? So we can eyeball this if we need to. Where am I going to put C so that it has an x-coordinate of 1, but it's going to make a square? So at 2, is that going to be enough there? Yeah, it should be up at 3, I think. 1, 1? Oh, well, it's got to be a square with A and B. Oh, I see what you're saying. But no, AB, so this is the side. It's from A to B, that's the side. So it's like the square is not, so this is not, I see what you're saying. You want to put it at 1, 1, but remember, this here and this here, that's not going to be a side of the square. Because the square is A, B, C, D. So from A to B is going to be one side.
We only have to be negative 1 and 1.
We only have one side of the square right now.
To make it easier on yourself and connect those two lines right there.
Like these here and here?
No, from A, go to point A,
Uh-huh.
to 1, 1.
To 1, 1.
And then draw it to B.
Right.
I don't understand why you're flipping it.
Because if I did that, if I drew from A to 1, 1 to B, that would not create a quadrilateral. Because
negative 1.
Well, no, she's saying 1, 1.
Oh.
She's saying 1, 1, sorry. So if I drew from A to 1, 1 to B, that would create what we see as a square, but the problem is AB is going to be one of the sides of that square. If I say AB is a side, that means this thing's a right triangle that I just drew. You understand? This red here is just to figure out, it's to make a right triangle so we can figure out the length from A to B. Okay? The square, let me just finish with this because I think it is here. A is the side, C is going to be right 3 for the C, and then D needs a coordinate of positive 1. Okay, and so then Kyle's right. He's got, it's the coordinate negative 1, 1 right there. Okay, that would be D. And so if I connect these dots, okay, there's that square.
Yeah, but you can put those two anywhere. You can put them below AB. You can put
Okay,
them
correct. Correct. But, EK, if you look here, we are limited with what we can do because we're told that C needs to have an x-coordinate of 1, D needs to have an x-coordinate of, or y-coordinate of 1. So the only way we can make that work is if we use the points 1, 3 for C, and the points negative 1, 1 for D to make that square. Okay, that's why we have to do it that way.
I mean, but you could also do negative 1, 2, and you would get
Negative 1, 2. No, it wouldn't work that way. Here's the reason why, and we'll explain that here in a second. Actually, that's going to be the next thing here. So,
But
okay.
What I'm saying is, like, you could do negative 1, 2, and then you could do 1, 4, and, I mean, like,
Or negative 1.
She asked me why can't I use different.
Right. So, all right. So I'm gonna
and then that's still using the same numbers they give you.
I see what you're saying. Let me show you here real quick because I don't have I don't want to like redraw all over this. But let me do it over here on my graph paper here. I'm gonna have to delete my tree here.
Oh, redraw.
Okay, math is more important than a little decoration here right now. Okay.
Way to go.
So real quick, let me just show you. So A has. Let me just replot the points there. So 1, negative 1, and then 3, 1. 1, negative 1, A. 3, 1, B. Okay. And then you were saying what coordinates there, Ikeva?
I mean, you could do 1,
4, I think you said.
yeah.
1, 4. Okay, so 1, 1, 2, 3, 4. That would be C. And then what did you say D was?
And then whatever point makes the square with negative 1.
All right. So I don't know. Would that be like this right here then?
Yeah, you could do that.
No, you can't.
I mean, it might not look like a square, but we've also done problems where a trapezoid doesn't look like a rectangle and it's classified as a rectangle. So really, this
Okay,
isn't-
trapezoids are sometimes a rectangle.
Right, but it doesn't look like a rectangle, so that really doesn't apply. If it doesn't look like a square, it could still have square properties.
Okay, so what are the square properties?
I think the diagonals are perpendicular.
Okay, so again, with the way that I've drawn this, if I draw in my diagonals right now, actually, we just count the slope. We can use the slope number to figure it out. So my slope from B to D is up 1, 2, and then left 1, 2, 3, 4. So that's a slope of 2 and then -4, right? Up 2, left 4. Okay. From A to C, my slope is up 1, 2, 3, 4, 5. So this is BD. This is CA. Up 5, and then we're not going left or right at all there, so it's 0. Are these slopes opposite reciprocals? They can't be, right? And so this is actually not a square. This is not a square, okay? That's why we have to draw it the way we did up here, okay? We have to draw it the way we did up here. Okay? So, all right. Are you better with that, Akeva, now, at least? Okay, so.
I just don't like guessing things.
So, I mean, there's an element of guessing, but there's also, you're using the picture to kind of help you. I wouldn't say it's like a complete random guess. You know where it looks like, you know what the properties should be, and so that's what helps you like, kind of figure those things out. Okay? Shh. All right, folks. Letter C here. Letter C says, using the properties of a square, explain how you determine the locations of points C and D. Okay? So, how can we determine that this thing is in fact a square? How can we kind of like prove that it's a square? So we can...
Count the slope.
We can, yes, do the slopes first. So let's do the slopes of all the sides there. So we're going to do the slope of AB, the slope of BC. Whoops, I'm going to run out of space there. The slope of CD and the slope of
-2.
AD. Okay? So you got to do all 4 of those slopes. And so let's see here. So from A to B was what there, Kyle?
A to B was, that one's up 2, right 2.
Rise 2, run a positive 2, so it's 2 over 2. Okay, slope of BC is up 2, left 2, so that's 2 over -2. Slope of CD, down 2, left 2, so that's -2 over -2. And then AD is down 2, right 2.
I got for CD.
Mm-hmm. For CD?
I got -2, -1.
For which one?
For CD.
C. So from C down to D.
What point is D on?
D is on the coordinate -1, +1. And this graph will also be bigger. If you guys couldn't tell here, I split the papers up. So this is supposed to be one full page, and I just printed it to half a page just to save on paper. That's all. So it'll be bigger for you. So it'll be hopefully a little bit easier to see and stuff as well. I just wanted to save on paper some. Okay.
So for AD, I got 2 -2, but it's the same thing that you.
Exactly. It'll be the same number. Okay. So now let's take a look here. So is AB parallel to DC? Are these slopes the same? Yeah. AB is parallel to CD. The slopes are equal. -2 divided by -2 is the same thing as 2 over 2. All right. Is AD parallel to BC? Yeah. Okay. And we need to show one is perpendicular. So what's a pair of perpendicular sides here we could say? What's a pair? AB and AD, yeah, sure. AB is perpendicular to AD, and so that makes it a rectangle, right? So from this, it's a parallelogram, and then that makes it a rectangle. And we have to check one more thing, and that's the slope of the what? The diagonals, okay? So the last thing I gotta check is the slope of the diagonals. So let's count the slopes here. So the slope from A to C, it's 1, 2, 3, 4. So it's a rise of 4. And I'm gonna have to like write this over here. I have a little bit more space here. So AC slope is rise of 4 over 0. And then what is BD slope? Yeah, it's 0 rise and then 4 over, okay? Now, again, it's kind of hard to see here, but you can look at the diagonals. Are these diagonals perpendicular to each other? Yeah, one's vertical, one's horizontal. And so I'm going to go ahead and just say that AC is perpendicular to BD, and so that makes it a rhombus. And so ABCD is a square. It's a lot of work, I know, but it's very doable. Okay? It's a lot of work just to be able to say something's a square. But we got to first show it's a parallelogram, then show it's a rectangle, then show it's a rhombus by the perpendicular diagonals, and finally, since it's a rectangle and a rhombus and a parallelogram, that means it's a square. It has to be. Okay, yes, bless you. Yep, we'll get to that in just a second after we go through D. D is pretty quick here, folks. What we're going to do now is we're going to take, on the coordinate plane above, perform the similarity transformation xy to negative x, negative y. Okay? So that means, I'm going to do some of this work down here because otherwise I'm going to, run out of space. Okay? So that means, for example, A... Yeah, I see what you're saying there. Okay? Okay, so I'm going to write all my points here. So A, we had coordinates 1, negative 1. B, we had coordinates 3, 1. C, the coordinates were 1, 3. And then D had coordinates negative 1, 1. Okay, and so we're going to just do the transformations using these points. Okay. So, negative x, negative y, that means it's going to be a prime. It wouldn't be 0, we're just doing the negative version of the x coordinate. So 1 becomes what? Yeah, negative 1. And then negative 1 becomes what? Yeah, negative 1 becomes positive 1. Okay? B prime, it's going to become negative 3, negative 1. C prime is going to become negative 1, negative 3. And D prime will become positive 1, negative 1. Okay.
Then you gotta do the other one.
And then we gotta do the next one. Okay. And so what does this tell us to do? Multiply through by 3. So that makes this negative 3, positive 3. That makes this negative 9, negative 3. This makes it negative 3, negative 9. And this makes it, 3, negative 3. Okay? So actually, we didn't even have to do the actual similarity transformation. We can just do this right here. And so, and these, by the way, these should all be A prime prime, B prime prime, C prime prime, D prime prime. I don't know why that they left off the prime there. It's probably just a little error. And so we just list them all. So A prime prime has coordinates negative 3, 3. B's are negative 9, negative 3. And C's, negative 3, negative 9. And D's will be 3, negative 3. Okay, just from that little work that we did right there. Pretty straightforward. Okay. It says you could, on the coordinate plane above, perform the similarity transformation. Oh, label the image A prime. Okay. So we can plot these points up there too. You're right. I think we should.
Label the image A prime, B prime, when it's really A prime prime.
Yeah, that's a good question. I think...
Like, would we be going the first time?
No, I think we want to do... Because you can see there's there's two transformations there, so I think this is what they want us to do. So I'm going to go ahead and plot that as well. So negative 3, 3...
Are we supposed to think that on the thing?
If it's unclear, you can feel free to come and ask me, and I'll let you know, because I don't have a problem with saying, what's what in that case. Okay? Because you're right, that is unclear, I would say. All right, so then negative 3, negative... Oh, and this one doesn't quite fit. And then D prime prime is 3, negative 3. sorry. Just plot the points there, that's all. Okay, and then you can connect them if you want. Okay, so there's the shape. Just plot in those points. All right, last one, folks, here, and I'll get you guys your assignment. We should have a little bit of time to get started then on that. Okay, so last one here, letter E says calculate the perimeter of ABCD. So, well, yeah, we'll get to that in a second. Yep, exactly right. So the perimeter of ABCD. Well, what do we know is one side length of the square ABCD? 2 square root of 2, right? And then we just found?
Yeah.
Way back here in letter A. So, from A to B, this length. We used this 2 and this 2 to then get the hypotenuse here, which is the length from A to B. Okay? So that is the length from A to B. And then what's true about all the sides in the square? They're equal. So how many sides does the square have? 4, and they all have a measurement of 2 root 2. So to find the perimeter of ABD, or ABCD, just do 4 times 2 square root of 2. Yep. Oh, I'm sorry. The perimeter then is just going to be 4 times 2 square root of 2, which is 8 square root of 2.
Like, what if the sides would equal each other?
Well, because it's a square, they have to, right?
Well, I know that, but I'm saying, like, what if it was a rhombus? That might be a big problem.
You have to find the lengths of all 4 sides then, using that little right triangle idea that we did for the other 3 sides.
Okay, but we would have 2 different side measurements instead of 1.
True. So what you could do is you actually would only need to find the measure of one side and then a consecutive side, and then you can just double those and add them together. If that makes sense, right? Okay. So the rhombus, you would only need to find the measure of the one. So basically, in the rhombus, you'll already have one of the sides because this part A is going to have you do one of the sides already. Then you find the measurement of the other side, one of the consecutive sides that's touching it. Okay. And then you can just add those 2 together and just double it to get the other 2 sides. Okay. So. Go ahead, sorry. Okay. So perimeter, boom, there it is, 8 square roots of 2, okay? How does this perimeter compare to the perimeter of, and it should be, again, A prime prime, B prime prime, C prime prime, D prime prime.
Multiplied by 3.
So, right, the perimeter for this shape is just going to be multiplied by 3, okay?
Why 3?
Well, good question. We dilated by a scale factor of 3, so the perimeter will be 3 times as big.
How come the first one and the second, we didn't dilate by 2?
For this one right here?
Yeah, that's the perimeter of the first square, right?
Right, the original one in black here.
Right, so why do we multiply it by 2 if we didn't dilate it?
Well, we multiplied it by 4 to get all the sides. This is the measure, remember, of one side, Ikeva. So to add up all 4 sides, we just did 4 times that.
So, how do you multiply 4 and square root of 2?
4 times 2 square root of 2 gave us the 8 square root of 2. 4 times 2 gives you the 8 square root of 2 there for the perimeter of the original shape. But then because the final shape here in red, that is dilated by a scale factor of 3, right? We multiplied the coordinates by 3 there. That then results in the perimeter being multiplied by 3 as well of the original shape. You could say 3 times 4 times 2 root 2 if you want to. Yeah, that's fine. Okay? But it ends up being this, which is then 24 square root of 2. So,
2 root 2 is the side of the original.
right? And then to find all 4 of them together, added up, you multiply by 4. That gives you the perimeter, the total perimeter of the square.
Right.
And then, because we dilated the square by 3, the perimeter is going to be just 3 times as big for the new shape. Because each side will be 3 times as big. So yeah, 24 root 2.
Can you just do the decimal, like, on the benchmark, or do you have to, like, do...
So, since the directions here did not say that you had to use simplest radical form, you can absolutely use a decimal, yes. Okay, yes. Yep.
Yeah, that's what I need help with.
Alright, so that's it, folks. Let me give you guys the homework. You have about 15 minutes to get started on that.